per classification. Before we start, we will have a prayer recital by Jishan of Batch B.
Assalamu alaikum wa rahmatullahi wa barakatuh.
Classification. Before we start, we will have a prayer recital by Jishan of Batch B.
أعوذ بالله من الشيطان الرجيم. الله وبركاته.
Before we start, we will have
بسم الله الرحمن الرحيم. أعوذ بالله من الشيطان الرجيم. الرحمن علم القرآن خلق الإنسان علمه البيان الشمس والقمر بحسبان والنجم والشجر يسجدان والسماء رفعها ووضع الميزان ألا تطغوا في الميزان وأقيموا الوزن بالقسط ولا تخسروا الميزان والأرض وضعها للأنام صدق الله العظيم. السلام عليكم.
Thank you, Zishan. I would like to take this time and to introduce the resource person for the evening. It is with great honor and that I am introducing Dr. S. Gokila, MCA, MPhil, NET, and PhD. She has a work experience of over 16 years, and she is currently working as an associate professor in computing applications in Hindustan Institute of Technology and Science. Her education qualification includes a PhD in Bharatiyar University of Coimbatore, NET in UGC, MPhil in Periyar University, Salem, MCA in Konguda Arts and Science College, Coimbatore, and Bachelor of Science in CT in Kumaraguru College of Technology, Coimbatore. She has published multiple books, including books in advanced Java programming, Visual Basic for self-learners, problem solving using Python, Python programming, theory and practical, computer networks. She has published over 24 journals, given 21 conference presentations, has conducted 37 workshops and seminars, and has had 16 technical talks. She has been a reviewer of multiple journals and conferences, and she has 4 PhDs in currently in the progress. She also has patents granted by the Australian patent for the work titled A System and Method for Analyzing Tamil Tweets into Positive and Negative Sentiment, collaboration with Dr. S. Rajeshwari on 24 July 2021, and another patent published for the work, Indian patent for the work titled Hate Speech Discovery System by using ML, machine learning approach. She has also another patent titled People Preferences in Selection of Hospital During COVID-19 Impact on Personal Life. She is also a member in the International Association of Academic Plus Corporate Society and the member in the Association for Computing Machinery and a lifetime member in the Computer Society of India. We are extremely honored to have you here to impart your knowledge to us, ma'am. I hand over the session to you, ma'am.
Thank you, Mr. Aravind Rajan, for introducing me. I thank the organizer of MCA Institute of Information Technology for giving me the opportunity. I thank the management, director, head of the department. I thank the students, those who are joined in this late evening, even after the college hours. So this enthusiastic will definitely lead you all to the higher level. Okay. So straight away, let us go into our sessions today. Let me share the screen. One of you please confirm whether it is visible to you all. Sorry, please host, please can you enable my screen sharing option, sir?
Yes, ma'am, we are doing it, ma'am. Just give me a second.
Thank you.
Go, sir, please make Gokila ma'am as a co-host.
Yes. I hope you all will be so interactive, and we are going to have a very good and interesting and interactive session. We are going to have many hands-on workouts. So I'm expecting answer from you guys in all the way. Yes, this now it is shareable.
Yes, visible, ma'am. Visible.
Yes, thank you, sir. On this topic, we are going to have 4 elements in our discussion altogether in order to cover this topic, in order to go with the knowledge and the experience and the application level of ability after the session, for which we are going to have these 4 elements to be covered over here. We are going to start with what is what. That is what the introduction is. And we are going to learn about how it is going to work, this particular topic, this algorithm, what we have taken in this session. And we are going to start with the manual calculation and the step-by-step procedure of this algorithm before making use of the Python code for that. Okay. So first we understand the title. So if I raise the question, what is KNN? What will be your answer? So do the students have an option to unmute and talk?
Yes, ma'am. Yes, ma'am.
Yes.
Okay, sir. So what if you can give your answer? What is KNN?
K nearest neighbor, ma'am.
That is an expansion, my dear. What it is? It may be your guess. It may be your new topic. Don't hesitate for that. Whatever comes in your mind about what it is, how will you define this? It may be a guesswork, okay, because at the end of the session, anyway, you're going to have a knowledge, you're going to have an idea what it is. Now you can have your guess what the KNN is. See, from the word itself, you can understand the definition. K nearest to neighbor. You forget about the K that is looking like a variable, okay? It is like a afterthought letter, it is B. Nearest neighbor.
To say simple, we can classify the nearest relationship between the things. Okay.
Yes. Who is so close to me, I'll be joining in that particular group. So the same. So here, that's what the algorithm is also. It is talking about the machine learning, and it is a classification, and moreover, it is a supervised also. See here, it is a supervised machine learning algorithm. As it is of a supervised, it comes under the directly comes under the classification model. That means we are going to segregate in which group it is going to fall under. But as it is a supervised, we should be knowing the characteristics of the group. The algorithm analyzes the group and the category, and based on that, if that characteristics of that particular group is so close to me, then I'll be joining with that. So I should be knowing the characteristics early in advance. So that's why it is supervised. Okay, so definitely the KNN will work for a supervised one for the classification, for the categorical model as well as the regression model. do you have an idea about what is categorical and the regression model is? What is meant by categorical? Categorical model, what it is? Any idea?
Nothing, but it's a classification. We can say finding categorical between like in animals, like we can say this, hey, this is dog or this is cat, like that. And for the regressions part, we can.
The categorical will improve the model performance. Yes, of course. Why? Because this the value which we are going to deal in the categorical is going to have a less computation. So definitely improves the model. What is the categorical means? The categorical data, continuous data, discrete data. We'll be talking about all these data, the different varieties of data. What is categorical data?
If you have multiple classes, so we can call it as categorical data. Am I right?
Multiple classes. Okay. If it is of a multiple classes in the sense, we are having a multiple groups, isn't so?
Yeah.
Okay. Let me put in another way also here in order to fine tune this explanation. See, if the group 1, group 2, and group 3. So 3 different groups. If these values are like a unique kind of within a range of the values, for example, if I'm having that is as all these group fall under the green color, these group will fall under the blue color, the other group will fall under the yellow color. So if that is the case, this is a categorical. We are having class labels and with that too with a limited edition, we can say. So that is a categorical one. Instead of that, we may be having a group. See, I will be having a group. Here also, we can have another set of 3 groups like this. But within this group, if we have any numerical value, for example, the value which is falling under, let me take, this is a hot summer, this is a cold weather, or this is a moderate weather. If you take a reading of these temperature, these and all some numerical value falling under certain range, but that particular falling will not be having a uniform gap. It does not mean that it will be having a range, but the value will falls on any category. It may be a numerical value or it may be a floating type value. It is not a fixed one. It may vary based on a particular range. So this is a regression. So this particular KNN model can able to predict the categorical type of value, or it can able to predict the regression type of value also. The regression in the sense your outcome is going to be a discrete value type, some number type. Simply if you say it is a number type. Okay. So this particular KNN algorithm, that is a K nearest neighbor algorithm, that means when the value is going to join with the closest group, that group may be a categorical group or that group may be a discrete value group. That is all about the number type. Okay, so for both of in order to find both these kind of output, we can make use of this KNN algorithm. Okay, that is why it is said to be both the classification as well as for the regression values also. And when we are going to talk about the classification, there are different types. That is about the binary classification, multi-class classification. The binary in the sense when we are talking about the group, the final group, the label class, that may be either a 2 class, it may be yes or no type, or it may be a 0 or 1 type, or it may be a 2 groups. In a previous slide, we saw that in a categorical, it is having green, blue, yellow. It's a 3. Okay. So either if you are going only 2 group like that, one is either a blue and or a green. So at last it is going to fall that we are going to have maximum of 2 groups. So that is said to be a binary classification. But the same algorithm can be applicable for a multi-class classification also. So your final outcome, the final group, the output, or it may be a group, can be a n in count. So we may have any number of groups. So when you are going to find a value, when you are going to identify the value in which group it is going to fall in, we are going to compare with n number of groups to along which group this is going to become a neighbor. Okay, so for both it is going to work fine. And moreover, when we are talking about the value type, it will work for a categorical value as in both the case, the input case as well as an output case. For whatever the algorithm it is, we'll be passing an input value and we'll be passing an output. We'll be finding an output on that. So when we are talking about an input, technically we call this as a feature. Or we'll be calling it as an attribute. So by using this only, we are going to find. So if this particular attribute, this property is going to have so-and-so value, it may fall under group 1. If this particular attribute is going to have a so-and-so value, it may fall under a group 2. Like that, we are going to find the value group based on the attribute or a feature. The value type of these attribute or feature can either be a categorical value or numerical value. For example, if suppose, if I'm taking a value as, I'm taking a gender. So what may be the possible value in this? Either a male or a female. So here it comes a categorical value. Your input itself a categorical one. And similarly, for example, if I'm going to find mass of any particular information, that is your output is going to be identified as a mass. So if I'm going to have a height and width of that, so if I'm going to have the height value and the width value of some product, assume that this is a simple shape of product and using which we have to identify the mass of that. Or I'm going to identify some category of value. So if I'm taking these two features as an input, the value which is going to fall on this is a number value. So it is going to be a continuous value. So your input feature, it is going to be of a continuous type. This particular algorithm can take a value, either a categorical type of value or it can take a continuous type of value also. So these are all its unique characteristics because there are some algorithms which will work only for a continuous value, only for a categorical value like that. Okay. Do you guys have any doubt in the basic characteristics of KNN? Okay, now let us see how this algorithm is going to work. What are the steps it is going to follow in order to have a classification? Either it may be a binary classification or it can be a multi-class classification also. Okay. The first and foremost step it has to do is, this is the first step of this particular algorithm, that is finding out the K value. The K is nothing but the number of neighbors what you are going to fix. That is what this K is. How many number of neighbors you are going to take it into consideration at last in order to assign the new value to the particular group. Because as it is a supervised machine learning algorithm, we should be knowing the groups early in advance. We know these are all the possible groups in this. When new value comes in, we have to identify in which particular group this particular new value has to be fixed. Because the machine has already learned and it is having all possible values for each and every group. That is the properties of those groups early in advance. And with that knowledge, the KNN algorithm has to identify in which particular group this new value has to be placed. So in order to do that, we have to find the closest neighbor. So we have to prioritize. For example, when we are finding the nearest neighbor, see, if I'm in one particular street, if my home is in one particular street, I'll be having two nearest neighbor, which two of them are very close to me, right? Just think of that street row. From your house, there will be two exact neighbor will be in the equal distance, right? Yes. Okay. So such a way, if I'm taking one value, that particular value may be having a closest neighbor with more than one group. So in such case, with which particular group it is having a maximum number of nearest neighbors. That is what this case. How much you have to count. Okay. How many closest neighbors we have to take in that? Which particular group is having a maximum number of closest neighbors. So for that, we are going to fix this K value. And the next step, it has to take it up is the finding of the distance. So after this, first K value, what we are fixing is, it is a am I audible?
Yes, ma'am. Yes, ma'am.
Yeah.
Yeah, because my got
Yeah.
disturbed. I have switched it to hotspot. So that's one. So the next step, once after you fixing once after we are fixing the K value in an algorithm, the next one is identifying the distance. We have to find from the new value, we have to find the distance between all the points in that particular data set what we are having. And in the next third step, we are going to identify the closest neighbor. After that, which particular group is having the maximum number of closest neighbors? That is the one in which your new value is going to be fixed. So these are all the very minimal and clear-cut steps which are all going to happen within this KNN algorithm. So fix the K value and find the distance. So the distance finding is between your new points with all the points in your data set. That is the points within all the groups. And we have to pick the closest group, the closest K nearest. That is what the K values. Among that, in which group we are having a maximum number of closest neighbors. That is one in which it is going to fall. Okay. Let us solve one simple problem. In order to understand this algorithm, let us do this work manually. Okay. Where we are talking about the K value, right? The expert suggestion says that the minimum K value what we have to fix should be 3 minimum 3. And we can increase it when you are going to change this. Definitely your algorithm performance also will vary. Okay, so after that we have to find the distance. Normally, how will you find the distance? How will you say the distance between your house and your neighbor house? How will you unit it? In what unit you will be showing that measurement? The distance between your house and your neighbor house?
Distance, ma'am, meters.
Yeah, meters. Yes, of course. So how will you exactly say that? How will you measure it in a unit? You are saying it right in a meters. How will you measure it?
By setting up a point.
Okay. So if there is only one parameter, then we are saying that the distance is going to be like this. But here in this particular data, what we are having is, when we are talking in terms of an attribute or a feature, we may be having n number of attributes. Okay. For example, if I'm taking an attribute 1, attribute 2, attribute 3, attribute 4, by looking into the values of all the 4 attributes, then only I can say this particular data set is going to fall on a group 1. Okay, so here when the new value comes in, the new value also will be having all these 4 possible values. Okay, the new data set will be having 4 possible values like this. So when we are measuring the distance, the same attribute of these 2 values have to be identified with the distance. What is the distance between these 2 attributes? That is the value of the new attribute and the value of the attribute of the existing group value. So individually, we have to find the distance between the respective attributes. And here the distance is nothing but some subtraction calculation. That is a basic level. Okay, there are many different distance calculation algorithms. The Manhattan distance, the Euclidean distance, and you can have a cosine distance. So there are many distance calculation algorithms, distance calculations equations are there. We can apply any of that in order to identify the difference between distance between these 2 data sets. When we are saying it is a data set, one set is having n number of attributes. So we have to find the distance between the equal attributes, that is the same feature of attributes. So here, when you are changing, see, when I was talking about the k value, when you change the k value, performance varies. The same way, when you take the distance calculation equation also in a different way, that time also the algorithm performance will vary. Okay. So all these we call in a machine learning, we call all these as a hyperparameters. For one algorithm, we'll be fixing many possible values and the equations. When you change all these, the algorithm performance, algorithm result may change. Okay. Here in our example and all, we are going to make use of the Euclidean algorithm. That equation is in such a way, right? Let me. The Euclidean distance is nothing but if this is your existing value and between your new value, find the difference and find the square. Likewise, you may be having n number of attributes, right? You add the difference of all the attributes And so likewise, we'll be going till n. The square root of that is nothing but your Euclidean distance. For every attribute, for an attribute A, for the existing point and the new point, find the difference. For attribute 2, for an existing point and the new point, find the difference. Find the square of that. The square root of all that is going to be a Euclidean distance. When I'm going to take you the Python code, I'll be showing where you have to change this equation type. Instead of the Euclidean distance, if you want to apply some other distance calculations, you can do that. If you have your own algorithms also, you can apply that. So for manual calculation, let us go with the simple data set. Here we are having 2 input variables, so that we call it as an independent variable. Okay? These 2 are an input. So here is a group category. This is going to be an output. So if we do the classification on this, is it going to be a binomial or multinomial? Can anyone give your answer? If you are going to do the classification on this, if I'm going to apply a KNN algorithm for this particular data set, whether it is going to be a binomial classification or a multinomial classification.
Binomial.
Voice is not audible, so can you repeat?
Binomial.
Yes, of course, binomial, because at last in output, we are going to have only 2 groups. 2 groups, okay? It is not in the mean of zeros and ones what we are having. All possible ones are in one group, all possible zeros are in another group. So the group 1 and group 2, we are having maximum of 2 classes, 2 groups. So it is a binomial classification. And based on the number of input, all the algorithm, when we are talking about the input, based on the number of input, we'll be saying the dimension. We'll be calling in terms of a dimension also. N-dimensional input. So as it is, there is only 2 input variables. There are 2 independent variables in this. So it is a 2-dimensional data set. If we have 3 variables, we call it as a 3-dimensional data set. So that is why the term I have given here is a 2-dimensional data, and it is going to have a binomial classification. This is an explanation for these 2 points I have given here. Do you have any doubt? When we are going to plot this data, so as there are only 2 values, we can take one value in x-axis and another value in the y-axis. If we draw the graph for this, when we are submitting this particular data for a KNN algorithm, the system will learn and it is going to plot, and it is going to clearly identify in which particular coordinates the group 1 is falling and which coordinate the group 2 will be falling. And as it is a binomial classification, it will be identifying one linear line in order to separately have these 2. So this linear line identification will be done automatically in order to clearly segregate these 2. That is in the machine learning one. So the clear separation for a group 1 and group 2 like that. So let us now have this in an Excel to do the calculation. Is it visible to you all? Do you need to zoom?
Yes, ma'am, it's visible.
Yeah. So this is the data we have taken, and this is the graph we are having. So the system has identified, that means we are clearly having there are 2 groups. So if when the new value is by understanding the value of the, see here, if the value 1 is 3 and value 4 is, that is value 2 is 4, then we are labeling that as in a group 1. That is being one particular group. So by understanding this, by learning this, when the new value comes in, when we are giving a new value, we'll be giving only the value 1 and 2. That is, only will be specifying the input variable. The system has to understand and analyze and has to label in which particular group the new value has to fall. Okay. So let me take this is a new value, that is the value 6 and 7. These are the 2 points we are getting. That is, this coming under value 1 and value 2. Now we have to find the label for it. I may not know what will be the output for it. We have to find this. In order to find this, first we have to fix it on the k value. That is what our first algorithm says, right? If I'm going to fix the k value, let me take k value. What I'm going to take is 3. We are having very less number of data over here, and let us start with the minimum required criteria. I'm fixing the k value as 3. Now we have to find a distance between these data points with all the data points available already in a learned system. So this is a supervised system. We are having already all these information in the respective label. Now we have to find the distance between 6 and 3. Similarly, 7 and 4. Find the difference, make a square, and the sum of the square has to be taken up with a square root. So if you do so, here is an equation. Look into that. Find the difference between 6 and 3 and find the square of it. And we have to find the difference between 7 and 4. Find the square, and at last you apply the square root. So likewise, if you are doing with the distance between all, see in my screen, I hope that you will not be having a distance for the 6th point. Can anyone say what will be the distance between your new data point and the last value, that is existing value in a data set? In my screen, it is showing the distance between the new point and all other 5 points in the learned data system. That is in a input data. What will be the distance for the 6th data set and the new point? Can anyone find it? Let me know the answer.
It will be probably 1, ma'am.
Is it?
Distance should be around.
I'm not asking about the label, okay? I'm not asking about the label. I'm asking the distance value. For every data point, we are finding the distance, right? You have to find the distance between the new value and the existing data set. For every data point, we are finding the distance. So in such a way, if you are finding the distance between this new data point and the existing last value in the data set, so that means you have to find the difference, that is 6 minus 3 the whole square plus 7 minus 5 the whole square.
It should be around 4 point something.
It's a 3.6. Okay. So when I'm finding the difference between your new data set and the first point, this is the one, and this is an existing label for all this. Okay. This is an existing label. Now we have completed a second step. I'll show you an algorithm here. We have completed a second step, right? We have fixed the k value and we have completed a distance. Now our next work is to find the k nearest one. So we have to find all the nearest. So simply that your algorithm also is going to sort all these distances in an ascending order. Okay. So once if we sort all these in ascending order, this is the one. All the distances, whatever we have calculated. So whatever is being calculated in a previous step, that has been sorted over here. And along with the existing group label also. Okay. So now we have to take the count of each group. See, when you are taking a shortest one, the first 3 shortest you take. So even in that, the group 1, the distance between your data point and the data point, the existing data point of the group is having the maximum count. Among the 3, one is falling on group 1, the other 2 are falling on group 2. So here, the maximum count, that is the maximum nearest neighbors are in the group 2 only. That means which is being labeled in a 1, the class 1. So the new value also you have to fix it with a group which has been already labeled as 1. So that is what. See here, we are taking a first top 3 distances alone. When we take a count for the 0 labeled group, we are having only 1 count. For a class with a labeled 1, we are having 2 counts. So among these 2, the binary classification, we are having only 2 classes. In a class 1, the count is 1, the class 2 count is 2. So it states that a new data point has to fall in the class 1. So in the place of the question mark, what we placed initially. So here in this, it is going to fix at class label 1. This is the 1. This value we found now. Think of that. We are having only 2-dimensional data. If we have more number of dimension, your number of input variables will increase. And so the distance calculation will be applicable for all the attributes. And whenever you are changing the k value, if it is instead of the k value 3, if you are going to increase the k value to 4, then what will be the performance of an algorithm? So here in this case, if we change the k value to 4, we have to take top 4 shortest distances. Then now you look into the count. Among the class 1 category, we are having only 1 count. Among the class, that is the next class, we are having a count 3. So in this case, there is no change in a allocation. When we have taken a k value 3, that time also the new value falls into the category of the label 1. When we are changing the k value to 4, that time also the same. There is no change in the result. But this will not be the case every time. So whatever the manual calculations we did now, for all that, the Python inbuilt library is going to have a line-by-line coding. It will be having this particular information will be saved in one data frame. And after which it has to segregate the input variable and the output variable separately. And when we are setting a algorithm type, we have to mention all these parameters. That is, what should be the k value and what type of distance we are going to apply. That is, what distance equation we are going to apply. We are going to learn few more parameters also for this. So after that, if you submit your algorithm, your system has to do all these calculations. That is, the inbuilt coding will read each and every value. It will be having multiple loops and if statements and all that to complete. And at last, we are getting one number of information at last. But whatever we have done manually now, finding the distance. After that, you sort all the distance and take a count of it, and you pick a maximum count of which particular group. All these will be taken into the step-by-step activities internally with the help of a for loop, while loop, with a many combination of the Python codings. Not only in a Python, whichever the data analytic tool supporting for these kind of algorithm will be having all these work internally. Okay. I hope you are all PG students almost. Is it so?
All are PG students only.
Okay, thank you, ma'am. So in such case, if you know all these internal process, instead of simply making use of, see, for all these one, we are going to have at the maximum 4 line of code in any of the data analytic tool. But if you understand how the algorithm is doing internally step by step, later stage, you can also become one of the such algorithm creator. In such a way, only you have to present to this environment that you are a computer science student. Because anyone who knows Python syntax, or they can make use of the inbuilt library, but you have to be the creators of those Python libraries. So for all that, you try to understand what is happening internally like this. Whatever the algorithm you are taking, you analyze in such a way. We may be having a pseudocode. When you are implementing that pseudocode into the programming language, internally, all these basic steps will go into multiple function statements, all that. Do we have any doubt in this manual calculation? Now let us move on to Python coding for this. Whatever we have done so far, all that can be completed within a 4 line of code. Here is the basic version of this KNN inbuilt algorithm, which is available in the sklearn package. Under this sklearn class, we are having one function called Neighbours classifier. So here, these are the parameters going to be mentioned for this particular algorithm, but see to that all these are optional parameters. Even if you are not giving anything, all these will be taking its own default values. So that is why those default values I have assigned over here. See, if I'm not mentioning this first parameter, the default K value, this is the first parameter, is nothing but your K value. It will be 5 by default. Okay. If you are not, see here it is a weight. I tell you, all these are said to be hyperparameters. If you are changing these value, your result may change. The accuracy of your algorithm will increase or change. Okay. So this is a weight. For example, if I'm giving certain input values, that is your input variables. Some of the input variables has to be highlighted. Some of that input variables should be given a maximum weightage. Let me have one more example over here. I want to identify whether what is going to be your grade based upon your performance in your internal mark and as well as your final examination mark. So we'll be allocating this particular to the system, and we'll be applying a formula that the 70% weightage should be given for the external mark, only the 30% for the internal marks. So how much ever you are scoring in your external, that is your final exam or an external whatever, that will be from that 70% of mark will be taken. From your internal performance, only 30% will be taken. So that is the weightage. So here also, when you feel some of the variable is so important, other variables also required to do the calculation. Other input parameters are required to do the calculation. But one particular or a few variables may be given a higher importance. So those weightage should be given a high weightage. For that, we can have this weightage. We'll be passing that in the form of uniform weightage, or it's a variation one and all that. Okay. And auto-fixing of algorithm adjustment, that is the linear separation. And when it is going to be implemented, it is going to internally, it is going to break up and make it is going to form of a tree structures to do all the calculation. If we want to do that, what should be the leaf level, where this should stop? And additional supporting parameter for this particular leaf we'll be mentioning. And here, this is a matrix. This is going to say about the distance equation. Minkowski, this is one of the equation. If you want to change it to other, the Euclidean, Magathan distance, or it may be a cosine distance, so we can mention that. Automatically, this algorithm will apply those equations. And for if you are changing this particular distance type, some cases it may require some additional input for that. For that, we'll be giving it as a additional parameters. Now, those lists we can mention over here in this. And whether you want to have a splitation work in this job or not. So these are all the parameters, but see to here, all these are optional parameters. Whatever the machine learning algorithm you are going to apply and if you are going to use, you have to understand all these parameters. That is highly important. Now let us look into the Python code for this. So what should be the package we have to use in order to make use of the K-neighbor classifier? What package do we need to import?
SK learner.
Yes, of course. And apart from this, in this coding, we are going to use two more packages. The one is to have a graph. Other one is to read a value from the file. Because here I'm going to have the information from the file. Let me show you the file also before applying the data. So here I'm having one text file with a clear structure of separation. It is to identify whether the given input parameter is going to be for any particular fruit. So here the input parameters are, it is going to be the height, width, and mass. These are the three parameters I am going to take in this. The other parameters, if you want, we can make use of the color code and all that. And if you are going to make use of the mixer type of input, so when you look into the except the first label, if you look into the other information, see it is apple and Granny Smith is an other food subtype it is, and the remaining and all are numerical. So when you are having a mixer type of values like this, for a calculation purpose, these categorical value has to be transformed into the numerical number. For an apple, I may be giving a number 10. Some numbers, because we know that this is going to be category, either an apple, mandarin, or it may be an orange. Okay. Likewise, it is going to have lemon. Here we are going to have a classification accordingly. So apple, orange, lemon, mandarin. There are four. So we are having a four particular possibility. So it is going to be a categorical type of input over here. So for that purpose, if you want to number it, we number it over here. But if you want to take it for a calculation, definitely all these string information has to be converted to the numerical type. That is what we'll be doing that in the pre-processing step. And the fruit name. And next comes into fruit subtype. So that is also coming under some string information. So wherever we are having a string, that string information can be of categorical value or it may be a continuous value. Accordingly, we have to scale it. If it is of a continuous value, we have to scale it out. If it is of a character value, we are having a many encoding methods. If it is of a continuous type, instead of having a 4 category or a 3 category, if it is a continuous type, we can do the encoding process. There is a another methodology. Okay, one hot vector encoding with the n hot vectors and all that. The different methodologies can be applied to change this character values into the respective numerical value based on that should be based on whether those character value are going to fall on a categorical type or a continuous type. So that all the steps you will be taking up in a pre-processing activity. Now we are going to concentrate directly on the KNN. So I'm directly going to take this numerical values, that is mass, width, and height. So in order to read this file, I'm using the pandas. Let me show the coding part. The matplotlib library I'm going to use to show the diagrammatical representation of the result and the graph and all that, and the Seaborn also graph. So when you take the remaining import statements, in a line number 10, it is having a import statement pass in order to read a file. That's okay. And the look into the remaining, after reading a data, we have to, within this itself, we are going to take few data for a training. That is two, with a label we are going to take, and few data we are going to consider as a new value, whatever we tried manually. So for that, we are going to split as a train the testing set. Or we are going to import train test split package. I think my name got disconnected and I rejoined. Is it so?
Yes, ma'am. Yes, ma'am. So now it's visible on the screen.
Visible, ma'am.
So
Visible.
may I know from where my the internet got disturbed, so I can start my continue my explanation from that point. So we have the classification process. This particular package is being imported, and see to here the remaining two. After which we are having every data is labeled. Within that only we are taking few set for a system to understand the features, the properties of an input variable, and to have a corresponding label. From that itself, we are going to take few values for here. This is the data we have taken up, right? So from this, we have to, there are almost 60 lines over there. 60 records we are having, totally 60 data sets. From that, if you are taking few data set for a testing purpose without a label, and at last we are going to submit that to the algorithm to identify the label. So whether the identified label and the existing labels are right or wrong, in order to identify that, the accuracy has to be done. So here, these two are the packages being used in order to identify the accuracy from the prediction. The statement is to read a text value, the read label. If you are having a data with a clear separation of space, even without a CSV file also, you get a value with the proper alignments. That is exactly with the rows and columns. And even though we are having a data, I told you that these are all the three input variables I'm going to take. That is the mass value, width value, and the height. And the root label column, that is going to be that is going to be the output variable. And here, split your data to the training and the testing data set. From the input variable, we have to take few record for a training, few record for a testing. Similar, the same set of label has to be taken it for the train and output. So here I'm going to split that as a 80-20, 80% of record. I showed you that there are 60 records in that. So among which 80% will be taken, the remaining 20 will be taken for testing purpose. And see here, simply you call this algorithm. Here I'm going to change only hyperparameter, the k value. So this is the one we call it is a model fixing. You are deciding your algorithm and you have to apply this algorithm to your data set. That is what the fit method is. See, it is enough to have these 4 lines in order to complete your k nearest neighbor algorithm. But in order to do this, we have done some manual calculations, right? Finding the distance, doing the sorting, and identifying the count and assigning a label, the exact label of the new particular variable. For all that work, this is the only one line we are going to have. But for this particular line, your Python is going to execute all those processes. And after which, the newly identified label and the existing one is right or wrong. For that, based on that, it is going to find code, for which we'll be having a one more accuracy parameter, that confusion matrix. Are you guys aware of what is confusion matrix is? Have you learned this concept in any other machine learning algorithms? What you learned so far? Am I audible?
Yes, ma'am. Yes, ma'am.
Have you guys heard the term confusion matrix?
To classify the data, ma'am, let's say
It has been classified. After classification, it is giving a label. That label may be, for example, let me show the same Excel. Okay. If suppose I'm taking only these set of values, but I doesn't know what will be the output. Actually, this is 1, but I'm trying to identify what may be the label. So here I'm going to identify for this particular data set, if I'm going to apply all this distance calculation and all that, if my algorithm, the final step, what it is saying is that is a class 1. That means it is going to fall on. So in the place of question mark, if I'm going to find 1, that is a new. The actual and predicted is right. Okay. But in some cases, your actual is 1, your prediction is 0. So these two are controversial. Okay. So like this, now we are having it for only one data. Like this, if I'm submitting multiple number of data, for all that it has to find this 1, and it has to be compared with the existing group. It's a pre-labeled, right? From existing one only. So we know what should be, if I'm taking this particular row, I know that this is going to be orange, this should be labeled as 3. When I'm submitting this to the system as a testing data set, this particular label will not be given. See here, I'll show the Python code. See, when I'm going to apply this code, I'm going to pass only the testing data set, not the actual. So in such case, what will be the prediction and the actual is? That should be compared. Sometimes the wrong might be compared and find as the right one. If you say 1 means 1, the prediction is right. Sometimes it may be entirely wrongly predicted. So how many correctly predicted, how many wrongly predicted? So the combination of those things, we call it as a confusion matrix. We call that as a true positive, true negative, false positive, and the false negative. If it is 0, you are identifying that as 0 itself. If it is 1, you are identifying that as 1 itself. If you are identifying it in a wrong way, so that will fall under the negative category. So these four combinations only we call it as a confusion matrix. So when you take the true positive plus false positive divided by sum of all this, that is going to be the accuracy. Okay. That accuracy calculation only being done over here. So for that only we have imported the accuracy score and the confusion matrix as a matrix, because these two are the parameters going to evaluate the performance of your algorithm. How many are being identified correctly? For how many data set your algorithm identifies the correct group. Likewise. Okay. Let me execute this code. See, here is the final score. So what can you say from this line? Any assumptions? Score of the model is 0.75. What it is? Any guesses on this?
It's more accurate kind of.
It is 75% accurate. We have taken 80% of your 80% of the given data set for a training, remaining 20% only for the testing set. So for example, in this one, we have given 60 records. So in that, few records are taken for a testing. In that few records, it has identified the group. We are finding this label, right? We are finding this label. This label has been identified only for a 75% of records, not for the remaining. Now let us change this K value and check whether your algorithm performance increases or decreases. Instead of 3, I'm going to change that K value as 5. I tell you what all these graphs about. See here, your model performance decreases. It came down to 66%. Let me increase few more. Let me take the K value as 10. It is getting reduces. So this is what we call it as an experimental. See, this is the case for the given data set. Instead of this 60 records, if you change it or if you reduce this number of records in a given data set, that time also your result may vary. So that is why we have to do the experimental study before you start doing any of the model fixation, and for which particular data your model is going to be correct one. And if you want to generalize this to the fixed set, so whatever may be the data set is, this algorithm is going to perform in such a way. For that only you have to fine tune all the internal calculations, the distance and all that. That you can able to do only if you know the internal line by line work. There is another methodology to find this K value, exact K value and all. That is a different session. We'll be doing an elbow method and all to find the K value, which may be the apt K value for this particular data set instead of trying with a random number. So let me display you the confusion matrix. See here, as we are having a 4-class classification, or matrix all as separately. True positive, true negative, false positive, and the false negative for all the cases. If it is of only the binomial classification, you will be having only 4. For each group, in apple category, how many apples have been identified exactly apple itself? How many have been identified in a wrong way? So likewise for each group, for an apple, orange, and the lemon, from the other fruit also. So that's why your confusion matrix is showing it as a 4x4, because we have taken it as a multi-class classification. We are having 4 possible outputs in our data set. So as you all PG students, you can take any of the data set, any numerical data set initially. You apply this algorithm and try it out. You try to change all the parameters and you try to experiment it first. How it is varying, why it is varying, and instead of going with all the 3 inputs, if I'm going to take only 2 features, that time also your experiment result may vary. So why it is, what is an important of all these parameters? In such a way, you understand the model. Do you have any doubt in this?
No doubts, ma'am.
You take any data set and apply that. So here is the graphs I have given in order to show this. This is called as a heat map. It is in order to show the confusion matrix I have represented here. One response I received that no doubts. Others?
Students, if you have any doubts, you can ask.
My strong suggestion to the PG students is, as like that manual work, you try to take a manual work for any algorithm to understand it in a depth way. Only you can create your own algorithms and you can come out with your research works and all. As you are all a PG students, this is highly important. Nowadays, many companies are working on to create their own models and to find a patent on that. So if you go with such a knowledge, the company will catch you quickly. So that's all from my end, sir. If any queries, let the students post it.
Students, you can post your doubts in the chat box. If you have any questions, you can post it there.
Thank you all the students, even after a college, you have all joined, and I hope you could have acquired some knowledge from the session. And moreover, all these models, all these algorithms are basic algorithms. There are various versions of these algorithms also exist. You try to explore and all that, do more research study.
Ma'am, actually, I have a small doubt. I would like to converse in Tamil, actually.
Okay, pa, solunga.
Actually, every algorithm, எல்லா அல்காரிதத்துக்கும் ஒரு எஃபிஷியன்சி இருக்கும். இந்த கேஎன்எனோட எஃபிஷியன்டான ஒரு அல்காரிதம் வந்தா what is the probability that companies don't use that algorithm?
உங்களோட நியூ அல்காரிதம் கேக்குறீங்களா?
Yeah, for example, let's assume ஏதோ ஒரு பிஜி ஸ்டூடெண்ட் இதை விட எஃபிஷியன்டான ஒரு அல்காரிதம் ரெடி பண்றாங்கன்னு வச்சுப்போமே, people will be taking them, right?
Definitely they'll take. இது வந்து நீங்க இப்போ ஒரு பைத்தான் பேக்கேஜ்க்காக நீங்க பண்றீங்கன்னா, பைத்தான் இஸ் an ஓபன் சோர்ஸ். நீங்க வந்து பைத்தான் சோர்ஸ் ஓபன் சோர்ஸோட கன்சார்டியம்ல நீங்க உங்களால பிரசன்ட் பண்ண முடியும். உங்களோட அல்காரிதம் நீங்க ஒரு புது மாடல் கொண்டு வரீங்க. இப்ப இந்த அல்காரிதம்ல பாத்தீங்கன்னா இதோட எஃபிஷியன்சி இது கேட்டகரிக்கல் டேட்டாக்கு ஒர்க் ஆகும், இது வந்து நியூமெரிக்கல் டேட்டாக்கும் ஒர்க் ஆகும், மல்டி கிளாஸ்க்கும் ஒர்க் ஆகும், பைனாமியலுக்கும் ஒர்க் ஆகும். இப்போ இந்த மாதிரி நீங்க ஒரு அல்காரிதம் ஐடென்டிஃபை பண்றீங்க, இன்னும் இதை விட எஃபிஷியன்டா இருக்கு அப்படின்னு சொன்னா, யூ கேன் சப்மிட் யுவர் ஒர்க் டு த பைத்தான் கன்சார்டியம், and they will be examining all that. They will be adding your code also to the Python. It's an open source. நீங்க இந்த நாலேஜ் இந்த ப்ரொஃபைலோட நீங்க போறீங்கன்னா கண்டிப்பா கம்பெனி உங்களை ரெக்ரூட் பண்ணிக்கோ. ஏன் உங்களை கம்பெனி விடுது? You can patent your algorithm also.
Okay, ma'am. Thank you, ma'am.
ஆக்சுவலி இந்த மாதிரி ப்ராடக்ட் டெவலப்பர் தான் வந்து கம்பெனி எக்ஸ்பெக்ட் பண்ணுது.
Who actually give permanent solution for their problems, right?
ஆமாப்பா, இப்ப நீங்க இது பாத்தீங்கன்னு வச்சுக்கோங்களேன், இப்ப எப்படி சேஞ்ச் ஆகுது நான் சொல்றேன் இல்லையா, எந்த அல்காரிதம், ஏன் மிஷின் லேர்னிங் அல்காரிதம் எனக்கு தெரிஞ்சு ஆல்மோஸ்ட் 2 decades தான் மிஷின் லேர்னிங், அதுக்கப்புறம் டீப் லேர்னிங் வந்தாலும் எவ்வளவு மாடல்ஸ் கண்டுபிடிச்சிட்டே தான் இருக்கும். இப்போ ஒரு CNN மாடல் எடுத்துட்டீங்கன்னா ப்ராசஸிங் வந்து எனக்கு தெரிஞ்சு ஒரு 45 இயர்ஸா இன்னும் இமேஜ் ப்ராசஸிங் இஸ் எவர்கிரீன். ஏன்னா நீங்க நேத்து கண்டுபிடிச்ச ஒரு மாடல்ல இன்னைக்கு நீங்க வேற ஒரு இமேஜ் எடுத்து போட்டீங்க அப்படின்னு சொன்னா அதே அக்யூரசி வராது. இன்னும் ஒரு ஜெனரலைஸ்டா இதுதான் அல்காரிதம். நீங்க டொமைனை கூட நீங்க பிக்ஸ் பண்ணிக்கோங்களேன். எனக்கு மெடிக்கல்ல நான் வந்து ஒரு எக்ஸ்ரே இமேஜ் எடுக்கிறேன், லெட் இட் மேபி a single finger image. என்னோட இண்டெக்ஸ் ஃபிங்கரோட ஒரு இமேஜ், இந்த மாதிரி ஒரு 100 பேத்தோட இண்டெக்ஸ் ஃபிங்கரோட இமேஜ் எடுத்து நான் ஒர்க் பண்ணி மாடல்ல ஒரு அக்யூரசி கிரியேட் பண்ணிட்டேன். இதே நீங்க வேற 100 இமேஜ் எடுத்து அதே மாடல்ல நீங்க கொடுத்தீங்கன்னா அதே அக்யூரசி வருங்கிற கேரண்டியே கிடையாது. ஏன்னா நிறைய டெக்ஸ்சர் சேஞ்சஸ் இருக்கதான் செய்யும். சோ அதை ஃபைன் டியூன் பண்ணி நீங்க ஒரு ஜெனரலைஸ் அல்காரிதம் கொண்டு வர வரைக்கும் இதெல்லாம் போயிட்டே தான் இருக்கும். இப்ப நீங்க you are all running in ChatGPT, இல்ல? Do you think that the ChatGPT is whatever version they have released as a file? இன்னும் போயிட்டே தான் இருக்கும் இல்லையா? இப்போ அதுல புது புது விஷயம் நீங்க என்னெல்லாம் நீங்க கொஸ்டின் கேக்குறீங்க, அந்த எல்லா விஷயத்துல உள்ள கொண்டு வந்துட்டே தான் இருப்பாங்க. ஒரு புது விஷயம் உள்ள கொண்டு வருதுன்னா அதை சர்ச் பண்ணி எடுக்கிற அந்த ஃபைன் டியூனிங்கும் வேற மாதிரி மாறும். ஏன்னா நீங்க கொண்டு வந்துட்டு இருக்க புது இன்ஃபர்மேஷன்ல இருக்கிற வேர்ட்ஸ், ஆர்டர்ஸ், இப்ப ஒரு ஜக்கார்ட் வேர்ட்ஸ் இருக்கலாம், அது எல்லாமே சேஞ்ச் ஆகும். அப்ப உடனே அவங்களோட அந்த அல்காரிதம் வந்து பழைய அல்காரிதமே இந்த டேட்டாவை ஆட் பண்ணும்போது அதே ரிசல்ட்டை கொடுக்கும்னா தெரியாது. கொடுக்கல அப்படின்னா they have to refine it. சோ அதனாலதான் எல்லாத்துலயுமே அடுத்தடுத்த வேர்ட் வந்துட்டு தான் இருக்கு. ஜெனரலைஸ் சொல்யூஷன் வர வரைக்கும் இதெல்லாம் போயிட்டே தான் இருக்கும். அந்த மாதிரி ஒரு ஜெனரலைஸ் சொல்யூஷன் நீங்க கொடுக்கணும் அப்படின்னா இருக்கிற அல்காரிதமோட இன்டர்னலா நீங்க நல்லா தெரிஞ்சுக்கணும்.
ஓகே மேம், தேங்க்யூ மேம்.
தேங்க்யூ. ஆக்சுவலி நான் எந்த ஒரு ரிசர்ச் ஒர்க் எடுக்கும் போதுமே ஒரு ஜெனரலைஸ்ட் கொண்டு வர மாட்டோமா தான் ஃபைன் டியூன் பண்ணிட்டே இருப்பேன். சோ அதே மாதிரி தான் நீங்களும் work on it. Good.
Any other questions, students, from your side? Floor is open to you. You can ask any questions and clarify your doubts.
Oh, sir, you can conclude.
Yes, sir. Arvind Rajan, are you there?
Yes, sir.
Yes, please.
Okay. Thank you, ma'am, for the wonderful session. Thank you for focusing on the importance of the algorithm and a deep dive into the intricate works of the K nearest neighbor. I now call upon Nafil Ashif of Batch B to give us the vote of thanks.
Thank you, Arvind Rajan. Assalamu alaikum and a very good evening, everyone. It's my privilege to propose the vote of thanks today. First and foremost, I would like to thank the Almighty for blessing us with a wonderful day. I express my sincere gratitude to our resource person of the day, Dr. S. Gokila ma'am, for her valuable time and for having conducted a very needful session on machine learning. Thank you, ma'am, for enriching us with the technical knowledge. As a special thanks to our respected director, Dr. Ahmed Mudassir Ali sir, and the assistant director, Dr. Usha ma'am, for their immense support. I also thank all the professors for their presence. I also extend my sincere thanks to all the participants for attending this webinar and making it a grand success. Thank you all.
On behalf of the MIT students and faculty, I thank Dr. Gokila for giving such a wonderful delivery on KNN. Thank you so much, ma'am.
Thank you, sir. Thank you all the participants. First, I have to thank you, the participants. Usually, we'll be having a but not leave the participant. But I want to thank the participants first over here because this is your session for you. And I like the question session so much because it is eye-opening for many why this machine learning is. So thank you so much. Thank you, organizer. Thank you for the director. Assistant director, and all the professors of the department. Thank you so much.
Thank you so much, ma'am.
Thanks a lot, ma'am. Thanks.
Thank you. Thanks a lot.
Thank you. Now, sir, you can stop the live streaming.